Hello everyone, this is Pranav from Sri Venkateswara College of Engineering, and in this video we'll be discussing about the topic solar space cooling of buildings. So coming to introduction, solar space cooling is a process that involves using solar energy to cool a building's interior, or it is an eco-friendly alternative to a traditional air conditioning system that rely on non-renewable energy resources. Solar space cooling works by using solar powered cooling system to absorb heat from the building's interior and it transfers it to the outside. Here are some of the key components and techniques that are involved in this method. Firstly, solar collectors. Solar collectors are primary components of space cooling systems and they absorb solar energy and convert it into heat, which is then used to power the cooling system. Absorption chillers. These are used in solar space cooling systems to provide the cooling effect, and these chillers are used as a refrigerant that absorbs heat from the building's interior and it transfers it to the outside. Thermal energy storage. This system is used to store excess solar energy for use during periods of low solar radiation, which ensures that the system can provide cooling even when there is little or no sunlight. Passive cooling techniques such as shading and natural ventilation can be used to reduce the amount of solar radiation that enters the building. This also helps in reducing the amount of energy required to cool the building. System controls. A solar space cooling system must be carefully controlled to ensure optimal performance. This may involve the use of sensors and control systems to regulate the flow of heat and refrigerant. Overall, a space cooling is very effective way to reduce the environmental impact of cooling buildings, and it can also help in reducing energy costs and improve the comfort of building occupants. However, the initial cost of installing a solar space cooling system can be pretty high, and the system may not be suitable for all kinds of climates and regions. And the use of conventional systems may be preferable in such regions. Coming to the working structure, the system consists of two parts, that is our solar collectors and storage, and the second one is the absorption air conditioner and the auxiliary heating. So the essential components of the cooler are our generator, condenser, evaporator, absorber, and our heat exchanger. Coming to the block diagram, as we can see, we have solar collection arrays, our storage tank, a pump, and a three-way valve, an auxiliary heater, our grounding, our cooling water, the cooling water inlet, and another pump to send it to the heat exchanger, and an exchanger to the cool space. So let us see the working principle. The operation of air conditioners with energy from flat plate collector and storage systems is the most common approach to the solar cooling today. So in a conventional way, we use our air conditioners and it uses the principle of our air conditioners in this, but with the energy of our flat plate collectors. In a sense, cooling is accomplished as the generator of the absorption cooler is supplied with heat by a fluid pump, that is by the collector storage system from the auxiliary. Heat is supplied to a solution of refrigerant in absorbent in the generator where refrigerant is distilled out of the absorbent fluid. The refrigerant is condensed and goes through a pressure reducing valve to the evaporator where it is operated and it cools air or water from the cooling space. The refrigerant vapor goes to the absorber where it comes in contact with the solution which is weak in refrigerant and which flows from the generator. The vapor is absorbed in the solution which is then returned to the generator. The heat exchanger is used for sensible heat recovery and greatly improves cooling. For solar operation, there are two additional factors, that is the temperature required in the solar collector to drive the process and the ratio of cooling produced to solar energy incident on the collector. So that means the higher intensity of radiation, the solar radiation, the better cooling. And pumping to more absorbent solution may be by mechanical means or by vapor lift pumping in the generator for low pressure systems like lithium bromide H2O system that require water cooling of absorber and condenser. But in the case that we saw in our block diagram, we are using pumps, and the coolers used in most experiments to date are like lithium bromide water machines or water cooled absorber and condensers. The pressure in the condenser and generator is fixed largely by the temperature drops across the heat transfer that occurs in the surfaces in the generator. The pressure in the evaporator and absorber is fixed by temperature of cooling fluid to the absorber and by temperature drops across the heat transfer surfaces in evaporator and the absorber. Thus, to keep the generator temperatures within the limits imposed by the characteristics of flat plate collector, the critical design factors and operational parameters include effectiveness of the heat exchangers and coolant temperatures. This might also be subjected to the intensity from the flat plate collectors or by the absorbents. Common practices in solar experiments uh, has been to use water cooled absorbers and condensers, which in turn require cooling towers. So this is the basic working diagram of our solar cooled buildings. So this can be a basic representation of our solar cooled buildings, where the arrays fall in the solar arrays fall in the flat plate collector, which in turn heats the water, and in the heat exchanger we can see that the absorber absorbs all the heat and the building is kept cool, and the super window and the pump is used to pump out the water to the flat plate collector, that is your cold water, and heavy insulation basic protects the building from warming up, and a hot water tank is used, or a collection tower is used as a cooling tower. And to heat the house, radiators or forced air ducts are used, that is fixed outside the house for dissipation of heat. So thank you everyone for watching this video. Hope it was informative. Don't forget to like and share the video.